Now, you know how to convert from radians to degrees, right, Daniel? And then you know how to convert from degrees to radians, right? You're either using your pi over 180 or 180 over pi, yes? Coterminal angles are what? They end at the same terminal side, right? So if I were to say negative 30 degrees and 330 degrees, are they coterminal angles? Yes, that was one of the examples we went over in the past, or whenever, I don't know when our last day was. But, so now you have your cards, okay? The most important thing, if you're not here today, then you're listening to the sound of my voice. You're going to get your card later, okay? But this is a card that you will carry on to pre-calculus, some of you, okay? You want this to be neat. You want it to be in pen, because if you put it in pencil, then it's going to smear. Because every quiz, every worksheet, every test, every exam you take for me will be, you will be allowed to use this card, okay? Pen is in the back at my desk, so you're welcome to get those. Colored pencils are back there. Just, yeah. All right, so the first thing that we're going to put on our card, and folks, I will tell you what we put on the card, okay? What was the first formula ever that we used? No. X squared plus equals 1. Now let me show you this, okay? You need to write this kind of small. Let me show you mine before you put anything on your paper, okay? Now, I can write very small when I need to. And I consider this to be a cheat sheet of sorts, okay? But if you look at this, I have everything chunked by colors, because y'all know how visual I am, okay? But there's a whole bunch of stuff on here. And there we have the potential to, y'all don't need to hear, possible, as organized as possible. And if you want to use a different color pen with every section of formulas that we put on here, that's fine by me. I'm totally fine with that. First thing we need to know, x squared plus y squared equals 1. Of course, this is our equation for the unit circle. I want you to put this on the card. This goes on the card in pen. You put it on the card however you want to. I mean, I put mine at the very top because that's the very first thing we learned. Some people did their cards in another class sideways. Yes. No, you don't have to date the card. No. But the equation for the circle, for the unit circle, is x squared plus y squared equals 1. We're going to put a few little things on here today, and then we're going to put this to the side for a bit, just because we don't really need to worry about it right now. The second thing, now, if we learned that the equation of the circle, the unit circle, is x squared plus y squared equals 1, there's something else that I can do to this equation to change it. What else can I do to change this equation? There's something else that you learned about x and y values. Can I change x squared plus y squared to cosine squared x plus sine squared x equals 1? If you don't want to put an x there, put a theta there. What did I do? What allows me to be able to change that equation to cosine squared plus sine squared equals 1? What makes that okay? What makes that okay, y'all? Because don't I know that cosine is my x value and sine is my y value? Isn't that just a straight substitution? Isn't it? And then I also want you to remember that. Remember your inverses. Real tiny. Sine's inverse is what? Cosecant. Cosine's inverse is what? That's right, secant. Very good, you silent students. And then tangent. You need to know those inverses. I'm going to allow you to put it on the card. I've never allowed anybody to put that on the card. But for now, that's okay. Okay? All of that stuff goes on the card. Take a moment and get that on there neat. Okay. Here we go. From section 3.1, folks, we're going to look at arc length and the area of a sector. Today's the 28th. Folks, this is a lot of review from geometry. You got to know where these things are. We are not speaking about a unit circle now. We're just talking about arbitrary circles. Arc length, and this kind of gets us ready for Pi Day. When is that? 3/14. Okay, kind of gets us ready because we are dealing with pi. P-I-E, pi. Okay? When I think of arcs and how we find arc length, I think of the crust of a pie. To me, that's what the arc is. That's how I can find arc length. If we talk about everything inside, what am I talking about? Am I talking about an arc now, or am I talking sector? I'm talking about the sector, okay? This is the sector, which is, I think I heard you say it. It's the, no, sector slice. This is the slice of pie. The sector is the slice of pie. Now, you got to know where they are. And again, this is all from geometry. We're going to tie some trig in here too. Arc length from geometry. Arc length is this. We were given the formula in geometry that the measure of the arc divided by 360 times 2 pi r was the formula for arc length. Okay? The measure of the arc divided by 360 times 2 pi r. Now, does any of this look familiar? Any portion of this formula look familiar to you? 2 pi r, it looks familiar. What is it, Spawn? It's the circumference. What this is saying is that we want a portion of the circumference of the circle. Well, I know what the circumference is. That looks really strange. Circumference. There we go. I know what the circumference is, but can you describe to me where you find, how you find the circumference? What is the circumference of a circle? Well, that's how you find it mathematically. But as far as the circle is concerned, where do you find the circumference? How can you find the circumference of the actual circle? It is the distance around, okay? It's the distance around the circle. So let's look at it again. So the formula for arc length is just a portion of the distance around the circle. That's what you need. It's a fraction. It's a portion of. And that's the way you need to think about it. And some people think about it more along common sense lines than a formula. Of course, I'm thinking formulas because I like formulas. Now, how am I going to tie this to trig? Same formula, okay, for trig. Same formula. The measure of the arc divided by 360 times 2 pi r. Still dealing with arc length. In trig, we'll be given a circle. We're looking at this slice. But now, we're not dealing with, bless you, we're not dealing with these easy little measures. Now is when, in trig, when we introduced theta. And I told you that theta represents what? What does theta represent? Say it again. Well, we do use the theta in the cosine, the sine, the tangent, but it's always the angle measure. It is the cosine of that angle, the sine of that angle. So when I have theta drawn in this circle, we're talking about this angle, theta, correct? So, folks, just a side note, if a central angle measure was 100 degrees, what would the arc measure be? Central angle is 100. The central angle is 100. The arc measure is 100. That's for central angles. Central angles are congruent to the arc measure. So then, Whitney, if my angle is theta, then what is the measure of my arc up here? It's theta. Okay, so let's do some substituting. Remember, we're thinking what we know from our unit circle. All right, so we've got theta is the measure of the arc over 360 times 2 pi r. What else do we know about the unit circle? That the radius is 1, okay? I'm going to plug that in. I'm going to put all of that over 1 because I have a fraction times a fraction. Anything else that you can tell me from trig? Any other substitutions? What about 2 pi? All the way around, which is 360. So I can substitute not only 1 for the radius, but I can also substitute 2 pi for 360 degrees, can I? Remember, we're gleaning all that information from that unit circle. Now I want you to think about this. We're multiplying fractions. What can I do to this? Oh, I can cancel the 2 pi's. What else? Yeah, I can cancel my 1's. Yeah, I could. But what's that leave me with? Theta times 1. And what did 1 represent? The radius. So I'm going to throw it back in there. And I want you to look at this right here. This formula right here, don't put a box around it. It's going to go on your card. Let me just get rid of that box. That way you won't draw a box. This formula right here is the arc length formula. Now, I do not know why they call arc length S. I have no idea. Some random person assigned arc length some random letter, and I do not know why they chose S. But what it is saying is that the arc length is equal to, don't put anything on your card until we get done. Arc length is theta times r. What does theta represent? The angle, okay? The angle, this is the important part, in radians. Because remember, we're dealing in trig now, okay? Is equal to the angle in radians times the what? The radius. And radius is the radius. Now, folks, this you can put in on your card, okay? You do not have to put a cloud around it or a bubble or a bubble. Important, and I'm going to say this 100 times between now and the end of class tomorrow, because we're totally going to be here both days, whole days. We are. Yes, we are. We are totally going to be here. Any number that you put into theta and any number you get out of theta has to be in radians, okay? Let me say that again. Any number that I substitute into theta must be in radians. Any value I solve for theta that I get out of that formula will be in radians. So you're going to have to read your problems very, very carefully. And this is where some people get bit in the hind end, okay? Here we go. Check this out. This is so easy. I want you to find the length of the arc of a circle with radius equals 10 meters that subtends, S-U-B-T-E-N-D-S, new word, a central angle of 30 degrees. I'm going to show you what that word means here in just a second. It's kind of like a trig word for intercept that we used in geometry. First thing I have to do every single time, and you're going to see me draw the same circle with the same angle every single time. I do not care if it's a 1 degree angle. That is still the angle I'm going to draw in my picture, because my pictures are never drawn to scale. I know that going into these problems. But I do know that the angle given is 30 degrees. I also know what else about this problem. I know that my radius is 10 meters. Now, what does that word subtends mean? Subtends means that angle intercepts what arc? Okay? The arc that has been intercepted, which we talked about in geometry, it's right here. Okay? Subtends means the angle intercepts that arc. It is, if I were to extend the central angle, extend the sides, it would be the piece of the circle, that part of that arc that's within the two sides of the angle, okay? It's the part of the arc that corresponds to your central angle. Part of the arc that corresponds to your central angle. Now, look at your picture. How are you going to know what you're finding? Because this is a common problem as well. Remember, you're going to have two formulas. You're going to have arc length and you're going to have area of a sector. People sometimes use the wrong formula. Well, if you read the problem, how can you do that? I don't understand. What are we finding? Arc length. We're finding the length of the arc, right? And FYI, we only have one formula right now, y'all. There's only one formula that we can use. But the first thing you need to do is you need to determine, hello, what are we finding? Find the length of the arc. Hello, which formula do we use? Well, right now it's the only one we have. S equals theta r. That's the first thing, determine the formula. The second thing, look at what we have. S is the arc length. That's what we're solving for. Do I have the angle measure? Yes or no? It's 30 degrees. So I'm just going to throw 30 degrees up in my formula, right? Nope. Why not? It has to be in radians, okay? Stars, rainbows, and ponies. 30 degrees has to be changed to radians. Bless you. Now you can think about your unit circle and know immediately that 30 degrees is pi over 6, or you can convert. What would my conversion factor be? Pi over 180, because I need my degrees on the bottom. 3 goes into 3 once, 3 goes into 186 times. Well, he was right, pi over 6. So now I've got my angle measure, which is pi over 6, and my radius, which is 10. I'm going to go ahead and list it as 10 over 1. Arc length. You get 10 pi over 6. Or you can reduce it to 5 pi over 3. Do you agree? Good. Silence. Crickets in the background. Have you ever measured anything 5 pi over 3 meters long? Do you have a tape measure that says, oh wait, let me measure it. I'm measuring it, hold on. I'm measuring it with my tape measure. Y'all know what a tape measure is, right? Okay. Yes, you do. Liar. Hold on, I'm measuring it. Yep, 5, 4, 5. Yep, 5 pi over 3 inches long. Have you ever measured anything like that? No, you have not, Ted. Montgomery, because you're in my class. 5 pi over 3. Everybody's going to watch this video, so I don't really want them to know who's in my class. But Ted Montgomery is. Hey, Ted Montgomery. 5 pi over 3. And he plays the piano, and he's a professional wrestler. Ted Montgomery. He wears a mask in class sometimes, and he tries to jump off the top desk. No, they don't. No. No. But he is Ted Montgomery, because thousands of people watch his videos every single day. What am I going to do? You just put this in your calculator. That's all. All you have to do. All I want to do is find out this number evaluated into real numbers. I don't want a pi symbol in my final. Remember, arc length is a linear measure. Okay? So put this in your calculator. And then we're going to have to round it. Why are we putting it in our calculator? Because what are we solving for? The arc length, which is a linear measure. Okay? We don't have to do any converting because we're not solving for the angle. We will at some point, but we'll have theta equals something. When we solve for theta, sometimes it will ask you for the answer in radians. Sometimes it will ask you for the answer in degrees, and then you'll do your converting back and forth. Okay? But we are solving for S, which represents the arc length. This is a linear measure. What's the value you got? Approximately, did you get 5.2? Okay, so it's 5.2 watts. It's a linear measure. Meters, it's 5.2 meters. Okay? Helpful hint. Arc length is a linear measure. So you'll end up with plain old inches or meters or kilometers, but you'll never have a pi in your answer. because they don't make those kinds of tape measures. I can't measure the crust of the pie like that. Where is that? What is that? Okay. Pardon? Montgomery. All right. Now, do you look at this and go, seriously, that's all it is to it? Do y'all look at it and kind of go, well, this is easy? Do you think this is kind of easy so far? It is very simple, okay? Very, very simple. Look at another one. You'll want to hit pause and copy this problem. Draw a picture. Draw something. Okay, there it is. My same old angle I always draw. Central angle theta. Well, I don't know what that angle measure is, but I do know that it is theta, right? I know that my radius is 4 meters. And I know that it is subtended by an arc length of 6 meters. Where is the arc length? It's the outside, but where is it? Now, I'm going to tell you right now. You got to figure out where the arc length is. For this particular problem, if I extend that angle, then the arc that I'm solving for, it happens to be in between the two sides of that angle. And I know that that is 6 meters because that's what I'm told. On your homework, you better be careful and read the problem very carefully because it's going to tell you to solve for the highlighted arc length, and you're going to be given theta, maybe 100, I don't know, maybe 100 degrees, but it wants you to find this arc length. So don't let that fool you. And I throw it in there, and half the class always gets it wrong because they solve for the wrong part. And they're like, I don't know what I did wrong. You didn't read the problem. That's what you did wrong. Okay? It's a sneaky, sneaky problem. What do I do here? What am I solving for this time? I have to solve for theta this time. So what's my formula? S equals theta r. It's the only formula we have. Can you solve an equation? Yes. So don't let this stuff fool you. It's just fancy equation solving. What is S? 6. Theta is what we're trying to find, so it stays theta. My radius is what? 4. How do I solve for theta? Divide both sides by 4. So theta is 6 over 4, or 3/2, or 1.5. Do you guys agree with that? Now, it's 1.5 what? Radians. 1.5 radians. Does this bother anybody? That it's 1.5 radians? Usually, if it's radians, then what does it have in it? A pi. What's this talking about? This is the tick mark circle, okay? This is from our tick mark unit circle. It's still 3/2, it's right. 3/2 radians is correct, but don't you dare put a pi in there. Don't you do it. Don't do it. Am I done? No, because I have to do what? Now I have to convert it to degrees. Oh, Lord. All right, so radians, it's here. Tricky. What's the conversion factor? Where does pi have to go? It has to go on the bottom this time. And look, the R is just for me. It's for hope, okay? I have to see it up there so I know what goes in the bottom. I know it's pathetic, Montgomery. I saw that look. But it helps me, so I don't even care. Multiply across. What's 1.5 times 180? Is something big? 270 over pi. Have you ever measured anything 270 divided by pi degrees? No. Calculate it. Evaluate this number. And let's round it to the nearest tenths. It's fine. 85.9 degrees. Do you guys agree with that? Questions? So 1.5 radians is equivalent to 85.9 degrees. Questions at all? I want you to do this one yourselves. 10 equals theta times 5. Divide both sides by 5, yes? So theta is equal to 2 what? Radians. Does that makes me kind of want to cringe a little. But again, this is 2 radians that we're connected to that tick mark circle, yes? How many of you had 2 radians? Awesome. Take 2 radians, and then what do I have to do to it? Convert it. What's my conversion factor? 180 over pi. And then I get 360 divided by pi, which is approximately who? 114.6 degrees. How many of you got approximately 115? Yeah. And 2 radians. Facile, difficile. Facile. See? We? Good. Here's another one. All right, so let's talk about area of a sector. Remember, sector, we're talking slice. Same picture as always. Pardon? Sector, slice. Area of a circular sector, slice. In geometry, this is the formula we use. Measure of an arc divided by 360 times, what was the second half of this formula? Does anybody remember? Area of a sector. Come on, come on, come on. Warm. No. No. Pi what? Pi r what? Pi r squared. Where does pi r squared come from? Again, measure of the arc divided by 360 represents a portion of, what's pi r squared, y'all? It's a portion of the what? Nope. Circumference is 2 pi r. What is pi r squared? Come on, come on. The area of the circle. It's a portion of the area of the circle. Okay? Very good. The area of the circle. Now, in geometry, that's what we learned. And we did those problems very quickly at the end of the year because we didn't get to them we don't get to work on them a lot. But in trig, our central angle is now changed to what? Theta, of course. And y'all, this is so silly. You're not going to find it in a book. But this is the way I represent the area of a sector. I put A subscript S. I know that's silly, but it's just what I do. You're not going to find it in a book, okay? Use the same. Theta over 360 times pi r squared. A sub S, area of a sector. Measure the arc, which is theta, divided by 360 times pi r squared. Now, pi r squared. Pi r squared. Here we go. Any changing I can do here? Well, we're going to have to go back and put that radius in at the end anyway, so we're going to leave the r. Yes, you're right. In the unit circle, the radius is 1. But you know how we went back? Where is it? We just went back and put it in at the end, not on that one. Yeah, look, we went back and changed the 1 to an r. So I'm not even going to move or change that r this time. come? Well, hold on. 360, all right, let's keep going. Theta stays theta. 360 is going to be changed to what? Pi, who? 2 pi times pi r squared. And I'm going to put that over 1 because I can write anything over 1 and it never changes its value. Now I want you to look at that very carefully. Is there anything I can cancel out? Because y'all know I love to cancel out. I can cancel out my pi's. Anything else? Can I rewrite this? Theta r squared divided by 2. That could be a version of the area of a sector formula, or how about this? 1/2 theta r squared. How about that? Can we live with that? You can use either one. It's 6 in one hand, 1/2 in the other. But let's talk about what this is. And this is going to be what we're going to put in our notes and on our card. A sub s is, of course, area of sector. We're going to take 1/2. Theta is our central angle measure. And it must be in terms of what, y'all? In radians, has to be. Times the radius squared. That formula goes on your card. I need you to lock into the fact that any value we put into theta or any value we get out of theta has to be in terms of what? Radians. Very good, class. Good answers. Awesome. Check out that. Find the area of the sector with central angle of 60 degrees and radius is 10 meters. And then there's my same old, okay? Guys, like I said, you got to figure out what you're solving for, whatever we're solving for. Area of the sector. Hello, which formula am I going to use? A sub s is equal to 1/2 theta r squared, yes? Okay. Within my picture, I have a 60-degree angle, and I know that my radius is 10 meters. What do I have to do? Say it again, I just didn't hear you. The sector thing. What do I have to do? Can I just throw 60 and 10 in there? Can I? Can I throw 60 degrees into my formula? Why not? It's not in radians. So what do I have to do first? If you don't already know that it's what? You should already know by your unit circle that 60 degrees is pi over 3. But if you didn't, then you better convert it. And then you get pi over 3. My radius is what, folks? The radius is 10 squared. Don't forget about that. That could be a potential careless mistake. 10 squared is 20, right? No, you're on crack, woman. 10 squared is 100, right? Woo! Yes. There we go. Solve. And we're getting area. So what are we going to do with that pi? Just put it in your calculator. And, folks, use the pi button on your calculator. Because it's, you know, whatever. Very simple. I'm going to reduce here. And I get 50 pi over 3. And I'm going to put that in my calculator because I have to remember I'm solving for the area. Have you ever known, has anybody ever cut or put carpet in a room or tile or any flooring? When you went to buy it, did you buy it based upon 50 pi over 3 meters squared? No, you didn't. Put that in your calculator. What is 50 pi divided by 3? Approximately 52.4, where we would meet, yep, meters squared. How's that? Facile or difficile? The cross canceling? No. No, you can put it all up in your calculator. Courtney, that's fine with me. Questions? Ready for another one? We're ready? Okay, here we go. Is this the second one? All right, so this one, central angle. It's 135 degrees. Radius is 9 meters. Find the sector. $135 pi over 180. What is that when you reduce it? 3 pi over 4. All right, so I'm going to put 3 pi over 4 in my formula times 9 squared, which is going to give me 1/2 times 3 pi over 4 times 81. Folks, I highly recommend just multiply straight across the numerators. When you do that, you get 243 pi. Multiply straight across your denominators, you get 8. And then once you have this one value, then put that in your calculator and see what the decimal approximation is. What is that decimal number? 95.4 what? Meters squared. Please don't forget about the units. At this point, we have to be very meticulous about all of our answers. How many of you got that out of curiosity? Good. Excellent, excellent, excellent. All right, last one. No questions? Cool. All right, here we go. Last one. Got a little twist to this one. Star. It says the area of the circle is 36 meters squared. Get that written down real quickly. We're solving for the who? The area of the sector. Find the area of the sector. So that tells me immediately A sub S is equal to 1/2 theta r squared. Do you guys agree with that? Look at what you're solving for and then find that formula. Write it down. Okay, let's look at the picture. We got a circle. We got a 120-degree angle. Do I know my radius? Nope, don't know my radius. But I know if my angle is 120 degrees, that when I convert it, why do I have to convert it? It has to be in radians, so it's going to be pi over 180. Folks, what is 120 pi over 180? 2 pi over 3? Is that right? Okay. 2 pi over 3. All right, that's done. 1/2 times 2 pi over 3. Dang it, I still don't have my radius. How do I find my radius? What do I do? What am I given? What am I given? I'm given the area of the whole circle. The area of the whole circle is 36 meters squared. Well, what's the formula for the area of a circle? What was it, Sapon? You told me earlier today. Pi r squared? Is that what you said? Okay. Pi r squared. We know that the area of this circle is 36. Where do I put 36? It's my area. I can't put anything in place of pi, but will it allow me to find my radius? Hold up. Now, I don't know. I can't say that it's 1 because I'm not told whether this is a unit circle or not. Okay? How can I solve for r? Algebraically, how can I solve for r? Divide both sides by pi. Now, I want you to look at something real carefully. Now, I'm a tree person. We've had this discussion. I would get caught up in the details, and then I would want to take the square root of both sides, solve for r, and I would get something really gross, and you guys would cry. But what? We need r squared. This is when you step back and look and go, what am I looking for? What do I need? I need r squared. Do I have r squared? Yes. So take that value and substitute it for r squared, 36 over pi. This is when you kind of have to slow down, step back, and go, okay, let's look at this. That would have been nasty. Now I can work with this. Now I can cancel things out. Hot dag on it. Look at here. My 2 cancels, my pi cancels. I can cancel my 3 with 36 and 12. What's the area of the sector, y'all? 12 what? Meters squared. Is that a portion of that circle? Yes. Look at it another way. What is a go ahead, just say it. It is a third of my circle, isn't it? Is 120 a third of 360? Yes. Is 1/3 of 36 12? It is a portion of. Isn't that cool? I think that's kind of cool. I think that's neat. Obviously, you guys do too because you are shouting in hallelujah. Woo-hoo! Yes. I think that's kind of neat to realize that in the end go, you made us, and you guys are sitting there thinking, you made us do all that work for that? I did. I did. Could you do it the other way? Absolutely. If you show your work and back it up, absolutely you can. Here's your homework. Oh my Lord, you have homework. Page 184. 41 through 46, 48, 49, 51, 56, 58, 60, 61.